Okay, I'm here with David P. Hess, President of Pratt Whitney. Welcome, David.
Thank you, Tim.
At Pratt Whitney, how are your revenues split overall in terms of Pratt Whitney Canada, Rocketdyne? What's the percentage?
Well, if you look at the largest business that we have out of Pratt Whitney's $13 billion in annual U.S. revenue, about 4.5 of that, or really the largest share of the business, was our large commercial engine business, followed by the military engine business, which is roughly about a $3 billion business, and then Pratt Whitney Canada, just slightly less than $3 billion. So those are the three core engine businesses in that order: large commercial, military, and then the small engine business, and then followed by our two smaller segments, Pratt Whitney Rocketdyne and Pratt Power Systems, which does industrial gas turbines.
Okay. And where do you see the biggest and most dynamic growth market for aero engines being? Which sector?
Right now, it's really a very transformational period in our three core engine businesses. If you look at what's going on in each of the three right now, in the large commercial engine business, we're in the process of developing kind of a next generation family of engines based on a geared architecture, which we've developed and innovated with $1 billion and about 20 years of work in the labs to develop the technology. But we have 4 applications that we're bringing to market now for that next generation product family of engines. One on the Mitsubishi regional jet, one on the Bombardier C-Series aircraft, the A320neo platform, and then the Russian MC-21. So 4 applications coming to market there. It's a very exciting time for Pratt. It's been a while since we've developed a brand new commercial engine, and we've got 4 in the mix right now. So that's kind of what's exciting in the large commercial engine business. Similarly, if you look at the military business, they're also in kind of a transformational period, kind of transitioning from our legacy military engines, which are slightly declining now in terms of their production rates, but the F-117 engine for the C-17, the F-119 engine, which will cease deliveries at the end of this year with the F-22 fighter program coming to an end. And then also the F-100 engines, which are purely for international sales now. We're seeing some of those production volumes starting to come down as well. But replacing it is really the next generation military fighter program, the Joint Strike Fighter. We have the sole source engine for that platform, and we're in the midst of, we've completed development, and now we're ramping up production for that program right now. So that's going to be a real growth engine for Pratt and Pratt's military business going forward. And then finally, the third of our 3 core engine businesses is Pratt Whitney Canada, our small engine business based in Montreal. And we see them on a growth trajectory right now as well. We're starting to see the markets that they play in with business jets, regional turboprops, helicopters, and general aviation. All those markets are starting to recover now after being hit hard in 2009 and 2010. We're starting to see recovery, and then they continue to develop and certify new engine applications for new platforms. So really the combination of market recovery and new product introduction they're seeing growth as well. So if you look at all 3 core engine businesses, they're really in a very transformational period now, kind of heading into a growth cycle, we believe, and it's a pretty exciting time for the engine businesses.
Okay. As jet engines have become ever more reliable, so the focus has switched to aftermarket support and services. How are you developing your aftermarket sort of support for customers?
Well, more and more of our agreements with customers for aftermarket support are dollar per hour agreements based on flight hour contracts. These are good programs in the sense that the customer gets the airline gets a predictable cost structure. They can predict what their maintenance costs are going to be strictly by a per hourly rate. So it gives them predictability. It also gives us an incentive to continue to work hard on improving the reliability and keep the engine on wing, because the more reliable, unlike the model in the old days where the more the engine failed, the more money you made. These days, typically with the contracts we have, both the supplier and the airline has an incentive to continue to keep the engine on wing and make it more reliable. So we're seeing a big shift in our aftermarket business to those types of agreements, and I think it works well for the industry.
Okay. You mentioned obviously the geared turbofan for the PurePower engine. Can you give us an update on where we are in testing and how the test sort of schedule will kind of evolve?
Right. Well, we've got, I talked about the fact we have 4 new applications for the engine now, If you look at the first two, the MRJ and the C-Series programs, they're furthest along right now. We actually have both engines flying. The C-Series engine has been flying for about a year now, and the MRJ engine actually had its first flight just last month. So good news there. If you look at the combined number of hours on those two engines between ground testing and our flight test program, we've got about 2,400 hours on those engines right now. And typically when you're moving through a development program, kind of the magic number where we start to get a high degree of confidence in the engine configuration and performance is around 2,000. So we've kind of passed that threshold of 2,000 hours now. All the data that we're getting off the engine, both on the test stands and on our flight test aircraft, is very encouraging. And everything we're seeing continues to validate everything we've been promising the marketplace in terms of the 16% fuel burn improvement, the acoustic benefits, the lower emissions, and the other advantages that are offered by the geared architecture. So we're really pretty delighted now with what we see in the development test program. And then followed closely behind the MRJ and C-Series programs, we'll have the first A320neo engine go to test before the end of this year. And that, basically a derivative of that engine will be applied to the MC-21 program. So we've got a lot of engines in test now and more on the way, and we're looking at other potential applications for the geared turbofan as well, talking with customers at Embraer, Airbus, and Boeing about possible future applications.
Geared turbofan's not new, and were proposed at one time for the A340 actually with the superfan.
Yes.
So what has changed this time around?
I think what's changed, I mean, you're right, the theoretical benefits of the geared architecture have been known for decades. In fact, it was interesting, I remember talking to Jürgen Weber, who was formerly the chairman and CEO of Lufthansa Airlines, and also a very good engineer and really knows engines. But back in his early days at the university back in the 60s, he told me that he did his master's thesis on the benefits of the geared architecture and what that could bring to aircraft engines. So for many years, for decades, people have understood the theoretical benefits of a geared architecture. The problem was developing a gear system that was light enough, small enough, compact enough, and reliable and durable enough to be able to bring the theoretical benefits to market. The advantage that Pratt had, in addition to having the vision to go and bring this engine to market and be willing to make the billion-dollar investment in the technology, the advantage we had is really our Pratt Whitney Canada business. They had a tremendous amount of experience with high horsepower gearboxes, because fundamentally, if you look at a turboprop engine, it's almost a geared fan without a nacelle around it. So they had a lot of experience with gear technology. We were able to take that experience that they had with high horsepower turboprop engines, and with our research center at UTC, along with some of the scientists in Connecticut and our engineering operations there, we're able to refine the design and scale it up for application to large commercial jet engines. So it was really a perfect recipe for success.
Okay. Your partnership with Rolls-Royce in international aero engines has changed, obviously, right. With you buying their interest out. How do you see the kind of proposed new joint venture evolving in the future for narrow-body products? I mean, would this be a GTF? Would it be open rotor? Would it incorporate composite fan blades? What's the...
Well, I think the agreement that we've established with Rolls-Royce, at least for some period of time, when we get we're to get a new application in the narrow-body segment, that the application would be for a geared architecture. That's part of the agreement that we have with Rolls. Now, at some point in the future, if there's a technology that comes along, open rotor or whatever may exist at that point in time, if there is a better solution, we'd certainly discuss that with Rolls. But right now, the architecture and configuration of choice is the geared architecture. So we would work together to develop a next generation geared turbofan for, again, possible application on a new narrow body aircraft, if and when Airbus or Boeing decide to launch one. So we're pretty excited about it. I think it brings the kind of the best of the best technology from both Rolls-Royce, which has some spectacular technology, and from Pratt Whitney, as well as the financial strengths of both companies to the marketplace. So I think it's a great solution. It kind of allows us to focus on the existing business with the V2500 and then help to transition customers from the V to the new gear turbofan, and gives us, I think, better connectivity to the marketplace. And Rolls-Royce will continue to participate really in that program as a supplier now, rather than as a partner for the V2500, but they'll still be involved in the program. And we'll be able to focus our efforts again on kind of next generation engines and technology working together with Rolls.
Okay. What has Pratt Whitney been doing on the environmental front, such as helping the integration of biofuels and things like that?
We have done quite a bit of flight testing on our engines, and really in the large commercial area, and even in military jets, and with small engines as well. With respect to certifying engines to work with biofuels, it's really kind of trivial. We've demonstrated to ourselves that our engines have the capability to be able to work with biofuels. In fact, when you're certifying, you're really certifying the fuel and not certifying the engine. The engine really doesn't have to change to handle the biofuels. And really, I think the challenge there is for the supplier of biofuels to try to bring those products to market in a way that's going to add value to the marketplace and make it affordable. Right now, if you look at the cost of biofuels, they're probably a factor of 10 times what it would cost for jet fuel now. So that's where the work needs to be done. Clearly, it's a big opportunity. People are working at it, and as fuel costs continue to increase and biofuels continue to come down, as new technologies and manufacturing and production methods are developed, I think we'll see that make more and more sense in the future. But today we're doing, I think, quite a bit on sustainability, because if you look at the emissions that we'll be generating with the gear turbofan, for every % of fuel burn benefit that you get, you reduce your carbon emissions by 1% as well. So we talk about the 16% improvement in fuel burn efficiency on the engine. Well, that directly translates to 16% reduction in carbon emissions for the engine. And I think we've calculated that on a typical narrow body, typical emission on an annual basis, that saves about 3,000 tons of carbon emissions per airplane. And we've also made with the new engine technology, there's about a 50% reduction in nitrous oxide emissions as well. So these engines really are green engines, and we're quite proud of the improvement that we'll have with respect to the environmental impacts of the engine.
Okay. You mentioned about production of the F135 ramping up to as JSF kind of rolls out. So
right.
Is there a growth plan for this engine for increased thrust? And also, do you ever see a second source engine for the F-35 coming back in later on, perhaps when a second chance for GE and Rolls to come back in there? Right.
Well, with respect to the first question on the the increasing in thrust, it's typical in just about all of our military programs that after the initial engine architecture and configuration, there are improvements that are introduced, spiraled into the aircraft program as time goes on. That was typical of our F-100 engine, where we had initial configuration, and eventually have ended up with the 229 architecture today that has much higher fuel efficiency, much higher thrust levels than we saw in the initial aircraft. And we expect we'll see the same thing with the Joint Strike Fighter engine. We're already working on improvements now to the baseline production engine that initially introduces another 5% fuel burn improvement, so we're working on that today, and also higher thrust levels for the engine. So it's typical, it's not unusual for us to work on those kinds of improvements. With respect to the extra engine, second engine coming back, we still believe that it doesn't make any financial sense for the taxpayer. The cost of both developing, introducing, and then sustaining a second engine in terms of training, depot maintenance, and things of that sort, it just doesn't make sense. But right now we're focused on just creating the value proposition for the engine. We're ramping up production, and we're going to continue to execute flawlessly on the program and drive the cost down for the engine. We actually provided a cost reduction plan to the U.S. DoD back in 2009. We're actually ahead of that cost reduction plan. We've actually brought down the cost of the engine from initial deliveries of the engine to engines today. They're about 25% lower cost. So our focus is really on performing. We're going to have an engine that is as reliable as our other iconic military engine programs, and gets the cost target that the DoD customer expects us to get to. And The second engine guys can do whatever they want to do. Meanwhile, we're going to focus on performing and driving the cost down.
Okay. On turning to Pratt Whitney Canada, do you think we'll ever see a replacement for the iconic PT6? Because that engine just keeps on trucking.
It is. It's amazing. We've delivered about 45,000 of those engines now, and it is amazing. We've got more than 100 different variants or derivatives of it, and it just keeps on going. It really is a brilliant design. We continue to look for ways to improve on it, and we do have some next generation plans that we're working on today that are on the drawing board. So it is certainly something at some point will be replaced, but right now we continue to find new homes for it, and it's a great engine.
Okay. Turning to spaceflight, how has the winding down of the space shuttle program affected Rocketdyne and your rocket business? It's
been very difficult for us. If we look at what we've had to do to trim the workforce at Rocketdyne over the last couple of years with the shuttle program winding down and really nothing substantial to replace it, we've had to reduce the headcount there with roughly 1,000 people, many of them being design engineers who have had knowledge that they've collected since the 60s in terms of the intellectual property and what goes into developing and producing a reliable rocket engine. So it's really tough to see, to watch. It's something that we're quite proud of. It's a great business. UTC right now is in the process of dispositioning for divestiture, but it's a wonderful business. It continues to be a wonderful business, and for the future buyer, they're going to get a spectacular company with some great technology, and hopefully at some point the U.S. will figure out what its next generation space program is going to look like, and that business will continue to go forward. But there's some great technology there, and if you look at their track record of 100% mission success, it's not a slogan. They've never had one of their rocket engines fail in a launch, and every U.S. manned space flight that's gone up, every human that's gone up into space in the United States has gone up on a Rocketdyne engine. Really quite impressive.
Okay. In jet engines generally, we seem to have hit a plateau in terms of efficiency and propulsive efficiency. How much longer do you think we can get away with using the current configurations? And do you see any sort of breakthrough technology on the horizon that would kind of deliver a real, sort of step change in even more fuel savings?
For commercial aircraft engines?
Or for any?
For any engines? I think we've fundamentally made a step change today with the geared architecture and the geared turbofan. And if you look at kind of the history of aircraft engines, it's typically there's a step change in engine architectures. For example, going from propellers to jets, obviously, and then from jets to high bypass turbofans. And I'd kind of characterize this as really the next big leap since the introduction of high bypass engines. This is really the next big leap. And what you typically see is a step change in fuel burn improvement, as is evidenced by the 16% fuel burn benefit that the geared turbofans bring to market. And then once you get to that step change, it's characterized by roughly a percent to a percent and a half fuel burn improvement per year as you go forward with this new architecture. And that's kind of what we see in front of us for the geared turbofan. This is really the initial introduction, the first step of that new engine architecture. And we think that we'll continue to improve on that 16% fuel burn. So by 2025, 16% looks like 25%, when we get to that point. Now, at some point, there may be something else that comes along that replaces the geared architecture that's better. We don't see it today, but we continue to look at different and better solutions.
Okay. Sort of a historical question, really. I mean, Pratt Whitney has made some classic power plants. If you could sum up Pratt Whitney in one iconic engine, which one would you choose and why?
Probably be the JT9D. I mean, certainly that was far and away the most successful production engine, commercial engine, I'd say of all time. I mean, we made a lot of those engines. It really helped to enable the launch of the iconic Boeing 747, and really was a revolutionary engine for its time in terms of the first commercial high bypass engine that was brought into service. So I think it was really quite impressive, and quite honestly, what we feel that we're doing now, we feel like Pratt's kind of creating the next generation JT9D in terms of, it'll be the engine that defines Pratt Whitney's future.
Okay. As well as being president of Pratt Whitney, you're also chairman of Aerospace Industries Association, the US Aerospace Industry Trade Body. With that in mind, what do you think is the biggest challenge facing the industry right now?
The biggest challenge we're facing right now, I think, is the threat of sequestration in the United States. And if you look at the budget, the defense budget that's been proposed now, there's already a budget reduction that's basically been agreed to and planned, $487 billion budget reduction, which equates to about roughly a 10% cut in the defense budget. Now, obviously, it's a challenging situation for the aerospace and defense industry. It's really one of the best businesses or industries that the United States has. Far and away, if you look at aerospace and defense, we have the largest favorable balance of trade of any industry, any manufacturing industry in the United States, with roughly a $50 billion favorable balance of trade. And if you look at the jobs that it creates, roughly a million direct jobs, and if you look at all the indirect jobs that are associated with the industry, you could increase that number to 3 million employees. So the prospects of sequestration, what that would do would basically take that $287 billion budget reduction and double it to roughly $1 trillion reduction. The consequence of that would, we're concerned, would be very severe. We could see certainly very substantial headcount reductions. I think we've calculated that it could increase unemployment rates in the United States by up to 0.6%, obviously with impacts on GDP growth and other economic drivers at the U.S. So we're concerned about it. It's very important to I think the U.S. economy, to the jobs outlook in the United States, and also to sustaining the industrial base. I mean, we know what's happened in the UK as the UK has had to shrink their aerospace footprint, and we're concerned about similar challenges facing the U.S.